Thank you. So before we get started, I want to ask you a question. So think back the first time you actually used Python. So think back to that time when you were introduced to Python and when you first saw it and got excited about using the language. And think about like how many years ago that is. So if you have that in your mind now, I want everybody to stand up. And if this was like within a year, you can sit down. So if it was 2 years, you can sit down. 3, 4, 5, 6, 7, 8. Ooh, we're getting close. So for the people who are not seeing the audience, there's about 2, 4, 6, 8, 10 and a half. No, he's sitting. 10 people still standing. So 11. Ooh, 12. So there's 2 people still standing. So how many years have you been using Python? 13. Cool. And you? 20. So I'm 27. So thank you. You can also, yeah, you're already sitting. So this talk is about PyScript. So I'll first introduce you to PyScript, what it is, and then I'll explain how I used it to develop some applications on top of it. That will give you an idea of what PyScript is and how powerful it can be to write your own Python applications in the browser. So my history is I'm originally Dutch, so I think you figured that out from the introduction, but also the suit. Americans really love that when I do presentations and I show something that is Dutch. It's part of your culture. And I grew up in the Netherlands. I did my computer science in Amsterdam. I did a PhD in Leiden on a programming language, which came out around the same time as Python. Both start with a P. Nobody heard of my language, sadly. So I surrendered to Guido's dominance. It was called Procol. Nobody heard of it. It was a distributed language using protocols, so you can write modern applications that the problems we solve today, we solved 30 years ago. So we were way ahead of our time with that particular language. Python is much more applicable, practical, because it solved the problem at that moment in time, which was like, how do I script applications together, and how do I take data and transform it into something else? So I very much subject to Guido. There was a conference in the US at some point where there was a competition, and the team from Google was always winning. This was about facts about computer science. And I was working at IBM at that time, and we signed up for this competition as well. And I practiced like mad, and I actually beat Guido's team. So I beat him there. I had my revenge. But now I'm using Python again. So I've worked at technical companies. I've worked at finance companies, and they all have the same problem. We have a lot of data. We want to transfer it into something else and then do something with it. And whether you work in Google or Uber or you work at JP Morgan or Bank of America, the problem remains the same. It's like we try to solve the same kind of problem. It's a different culture, different environment, different recognition that you get as an engineer. But it's fun to see those different kinds. So my job at JP Morgan is ending this year, and next year I'll be doing PyScript a lot. So what is PyScript? So we have browser applications. Everybody knows that, right? So they have different kinds of browsers. They have what's called a DOM, which is a document object model, which you normally describe the contents of using HTML. So this is a declarative language for saying, like, I have a box and inside I have text, and that is then interpreted by the browser to render a document to the user. You have dynamic code that can run. That's called JavaScript. We all agree that JavaScript is a horrible language. It has all kinds of like quirkiness that Python does not have. Python is much more elegant. But this is the state of the art that we have. Now recently a technology came out that is called WebAssembly. And the advantage of WebAssembly is that it's like a bridge to the operating environment inside the browser that allows you to compile other languages to the browser environment. And in particular, languages that are based on C, or applications that are based on C, compile really well to this and then can run inside the browser. So that includes a platform called PyData, which is the CPython runtime, the CPython that we all know and love, with which you can do pandas and matplotlib and do data analytics. That is written in C, and all the extensions are C libraries. So you can easily compile this using the WebAssembly stack. I say easily, but it's an engineering effort. But you can compile that to that stack, and then all the browsers these days support that particular execution model. So with that, you can write Python applications in the browser, and that is already done with something called Jupyter Lite. So if you have Jupyter notebooks, they run in the browser. They're implemented in JavaScript, so all the UI you see there is actually traditional HTML and JavaScript, like on the right. But when you execute a shell, there's actually command send to a worker which runs remote on a kernel, as we call it. And with Jupyter Lite, you can actually run this in the browser without leaving the sandbox of the browser. You don't have to go to a server. The kernel can run inside the browser. And so this allows you to distribute applications a lot easier without having the requirement of having a kernel set up as well and having to pay for cloud services and whatever. So that is how PyData is already used in Jupyter Lite. But with PyScript, this is almost standardized, so it makes it a lot easier for you to write your own applications like Jupyter Lite on top of the same stack. So PyScript comes with, it's basically a packaging mechanism. So it bundles up everything you need from PyData or from MicroPython, which is an alternative implementation of Python. And then it makes it a lot easier to deploy your applications this way. So I built 3 applications just to try it out. First, I got intrigued by PyScript. I said, oh, I want to try it out and write some stuff. So that is Microlog. I will give a demo of that. And then I started by building a spreadsheet in Python. So Python in Excel came out. Who has heard of Python in Excel? So I thought Python in Excel, that's for losers. I want to do Excel in Python, right? Flip it around. So that's what I tried building. So I said, like, I'm going to build all of Excel into Python. Well, write it in Python, run it in the browser in Excel, not Excel, in the browser, and see how far I got. So those 3 things I built. LTK is actually the UI library that I used to build this spreadsheet in. And you can do the same thing. So you can say, like, I'll give you 3 examples of applications that I built, but you can build your own application in Python the way it is today. You import NumPy, pandas, whatever you do. That can be packaged up and run inside the browser, so you can distribute your applications without having to require installation of Python at all. So this is just clicking on a link, right? And it runs. So that is the goal for today, is to give you inspiration that you can do this yourself. And the technology you use here is this bridge between WebAssembly and JavaScript, where you can find out what's in the DOM right now. So you can locate elements. You can register for events, so events come back. Or you can make changes to the DOM. So you say, like, I find an object and I change the text, or I add a new element to the text. So this is how you build up your application in that way. So LTK, which I will demo, and PySheets and Microlog all use that functionality. So there's no more JavaScript involved. In fact, there is, because we're doing all the operations here in Python, but they get sent over this bridge to the JavaScript runtime that then operates the DOM for us. But the amount of code that we need on the DOM side, the JavaScript, is very minimal. So if you want to try out, I would recommend you go to PyScript.com. It's a pseudo development environment, like a poor man's IDE, if you look at it. You get a tree view here with files, you get an editor, and then you have a run simulation. And this is very easy to get familiarized with the capabilities of PyScript, so you can try things out. This is like a sandbox environment. And what HTML looks like in that environment is you import basically three technologies. So one is PyScript itself. So it gets bootstrapped by importing some JavaScript library. And that one can then start detecting scripts in your language. So it will detect like the script language of type Py. And type Py means it starts PyData. So remember those two operating environments that we have, PyData and MicroPython. So in my HTML, I can indicate what Python VM to run my Python script in. And then I have the option, this is an optional, I can have some helper functions that I can call for my Python. So I can decide what to put in Python and what in JavaScript. And that is specifically for performance related things. So like if you do very heavy drawing in the DOM, if you go back to that link here, this is an expensive communication. So this is between two different operating environments, and there's transformation of the data happening. And each call may be like a millisecond. So that doesn't sound like much, but if you do a lot of interesting drawing and you do 1,000 calls, that is a second. And that no longer works. So this particular application here, I try to estimate how long it takes. I do a benchmarking of the execution of that pipeline, basically back and forth, and I do some optimizations here to make it like run faster. So for that you need JavaScript, but in 99% of the cases you won't need that. So you can write applications like this. So this is written in Python. This application is like 6 tabs, and it shows you a UI here on the left, and then I have the code on the right that draws this. So LTK is the little toolkit, and it's named, a couple of people have already asked me, like, what's the name come from? So it comes from that PhD research from 30 years ago, where I had a little language, little toolkit, so it came back in the same name, so there's no real meaning there. So on the left you see a custom widget, the one in the orange box, which is defined here on the right. It says VBox init with an image and a text. So it's a very declarative way of indirectly making DOM operations. So imagine that these statements, when they execute, they go over this communication channel to JavaScript and operate on the DOM. So in this case it adds new widgets, new DOM elements. And you can do styling, so the 3 kinds of ways. So you can do CSS operations, you can set a class, or you can do everything external. So there's still choice is not good in Python, but there's some choice that is actually required here. But sometimes you want to be very direct. You want to set things directly on the widgets, but often you want to take that out and have different themes, for instance, dark and light themes. So you need some choices at certain times. So this is another example. This creates a couple widgets on the left, and on the right you can zoom in, you can see it creates a radio group with 2 elements in it, a span and a label, and it has a radio button for MPy and PyData. So if you go to the live version of this one, you can actually click in that thing and it will switch, running either on MicroPython or on the PyData version. And you can set event handlers like I mentioned before. So you can say on change, you can call set runtime, and what does set runtime do? It actually reloads the page and chooses the runtime. So again, this is like very small amount of code. The whole implementation of LTK is about 600 lines, and that's it, all Python. So it's not that hard to understand what is going on inside of this. It's also open source, so you can just look at it yourself. But performance is key, right? So I mentioned why we had 2 different runtimes. Why do we have 2 different runtimes? Why do you have PyData and MicroPython? So So the trade-off with these two environments is, yeah, basically space over time. So MicroPython was developed for embedded devices, and the entire implementation of the runtime is about 240K. And I measured the size of this picture. If you do a screenshot in PNG, it's more. So it's just like, so it's a really tiny runtime for Python. So that makes startup really fast as well. But there's limitations. You can't run things like pandas. You can't run things like matplotlib. So why is it relevant to have these two different environments? So you can use one for like the startup of your application for rendering the UI and getting the first time to render or the first time to interaction is very important for web applications. And then you can have a worker thread that in the background runs on PyData that can do the heavy lifting for you, like Jupyter Notebook does with their kernel. So I care a lot about performance. This is like I spent probably more than half of the time that I built LTK and PySheets thinking about like how can I make it faster and how can I make it start up really quick. And if you put this into numbers, like if you start up MicroPython, that's around 100 milliseconds, so that's 0.1 second. And there's this theory that people can't notice anything within 200 milliseconds. That's about how our brain, anything less than 200 milliseconds you don't care about in user interaction. Starting up PyData takes about 2 seconds. And this you actually notice. So if the first thing that you do to render your page is to wait for Python to start up and it takes 2 seconds, people are going to notice. So you have to do all kinds of magic to make your application appear to start up faster, but it will never do anything in the first 2 seconds. And if you include pandas, for instance, that takes about 6 seconds to get that all bootstrapped. So we need a faster way to get this delivered to the user. And the golden standard for me is Google Sheets. And if you look at it and if you really analyze like how it's launching, it launches within a second and everything is rendered. But it does that incrementally. So it brings up the UI first and then this and then this, and it comes up like, and engineers have spent hours and days and months. And I think you can get promoted at Google if you make this 10 milliseconds faster. This is how important that is over the large number of instances that people actually run this. So worrying about startup time in your application is critical, and especially for web applications. That's the summary. So I built this one. You can see it runs. This is the benchmark I showed earlier. So if you do this in MicroPython and you measure the startup time, I couldn't even measure it. It jumped up and it ran immediately. But then it runs for about 6.7 times. So MicroPython starts up really fast, but it's actually running slower. PyData starts up slower, but it runs faster. So these are like confusing trade-offs that you have to manage and think about if you're launching your application. So LTK takes care of that. There's a debugger that I will show you that helps you with analyzing like the performance there. But this is my goal. So I wanted to build Python in Excel, Excel in Python. So this is Excel in Python. You have a spreadsheet, you have dependencies. So you have a data frame on the top, you have 2 images at the bottom. That one is done with pandas. This one is done with matplotlib. Who came up with that name? Matplotlib. So 2 pictures there. And it's a dependency graph. This is how I think about these kinds of numerical problems. The notebooks have an advantage if you want to tell a story, but it's a very linear story and it goes in one direction and all like from top down. Here I wanted to decouple that sort of limitation that you have in presenting your story and make it be placed anywhere. So here's a quick recording of it. So you can see I have some dependencies. It's starting up the worker. it's sending a request to the worker to execute, and then it proceeds on. You can analyze like how long it takes to start up. You can see when each worker receives an event. So I'll zoom in a bit on this. And this one comes with LTK. So if you explore LTK, you clone it, and you write your own application on top, you can do similar analysis like this. And here I see a problem, right? So I say like, it sends me the result for cell 32, 32, and 32. So I see this 3 times, and I really didn't expect that. So this is helping me as a developer to make my application more performant by using like observability. Like debugging doesn't really help in these kinds of situations. I can set a breakpoint, but I have to know what the problem is already, where to set the breakpoint. I can do print statements, but print statements are, yeah, they don't scale really well for this kind of complexity. So I'm trying to build some visualization tools that show you the internals by observing what's going on and showing you what's happening. This is another app that I built. This is a profiler. This is also run in PyScript. So this is a visual view of the execution of a particular Python application, but the whole UI is also done in PyScript. So it runs in Python. The visualization is also done in Python. And that one I did because I could. I wanted to show that it was possible to do this. But I got like really convinced that this is a really viable platform for building rich client applications in the browser. This one I can also explain by just looking at the log of the application, what it probably does. So I use ChatGPT for that. I just send the log. I said, this one calls this one, this one calls this one, this one. What can you what can you tell me about this? And it came up with things like the UCT node is responsible for the Monte Carlo tree search algorithm. And then I look back in the source, and there's no mention of Monte Carlo. So it was actually quite surprising that it came up with this kind of insight from just the log statements. So this is an explanation tool. It's not really a profiling tool, because it tries to explain what the design is in your application. You can see all the events that are happening. So this is more like an observability tool again. It's an example built on top of PyScript. It does not use LTK, so you can take a look at it. It's also open source, so you can just look at the source, how it's implemented. So summarizing, you can use Python in PyScript and run very interesting applications. If you want to see any live examples and the startup times, there's a link to the top, which is my personal page, and there's direct links to the individual examples. It works much better than doing live demos here. And I see we have 6 minutes left. If there are no questions, I can actually run the demos, but then I guess there might be questions. So if you're interested in deploying your data analytics applications to your customers without requiring them to install Python first and deploy them through the browser just as a static website, PyScript is really what you want to try out. And you can leverage LTK. That will get you going much faster. And I'd love to work with you on that. Like I said, it's open source, Apache license, so go try it out and get inspiration from the other ones. So are there any questions on any of this? Question in the back? Yeah, we have a microphone runner.
Yes, thanks for your talk. I was just wondering, the graphical interface we saw, they all look a bit like 2000s, early 2000s. Do you need to know like CSS and all that kind of stuff to make it look more fancy, or is there a more easy way?
So that's a very nice compliment, thank you. So I'm not a designer, I'm an engineer. That shows, right? So all my UIs, that's my colleagues always joke about that. I'm not a designer. So this is normally when you write a web application, you have people that have experience with usability, and they are artistic and they know color palettes and whatever. And this is done through CSS, yes. So you can set the CSS directly on the widgets, but you probably want to set a class on it, and then have a designer come up with the real correct spacing and whatever. So I'm not trying to solve the the design part of the problem that like Python tries to like leverage the technologies that are underneath it rather than reinvent things. So I didn't want to reinvent how you do event handling. I didn't want to reinvent how you do styling, but I did want to reinvent how you actually construct the page, and that's what I focused on. Yeah. It's a good observation. Yeah. Any more? Otherwise, I'll just very quickly show you what it looks like. I'm going to sit down for a second. Oh, there is a question. Yeah, sorry, I missed that.
Yeah, thanks for showing the examples. It's nice to get a feeling for what you can do with Python in the browser. But I was wondering, if you're coming from the other side, like if you're a front-end developer in the JavaScript world, would it also make sense to learn about PyScript?
I think less so, because the goal of PyScript is to leverage the Python ecosystem and the abilities that you have to do data analytics in the Python stack, and to give you a different rendering platform for the outcome of that application. It's a catch-up race with JavaScript. Some people say, like, when they advertise this, and like if you go to YouTube and you say PyScript, it'll say PyScript, the JavaScript killer. It's not a JavaScript killer. It will never be. There's no way that you can replace the momentum of the lack of momentum of JavaScript. And there are plenty of rendering technologies on top of JavaScript that are going to be hard to unlearn and replace with Python. So that's not the main goal. It's not to win over JavaScript developers and make them become Python developers. It's more for people that have Python experience, like data analysts or data scientists or engineers that want to have a different service for rendering their UIs. So if you go to my personal site, chrislaffra.com, there's a link to LTK, so I'll click on that. And this is on GitHub Pages. So we see the first time that I load it, it's saying like 0.964 seconds. And that's because the memory cache of the browser still has to fill up. But if I run it fast, if I run it again, you can see that it comes up faster and faster. So now the caches are built up in the browser. And this number that you're seeing at the top right is the time it takes to start up the Python runtime inside the browser. So this runs on top of WebAssembly. This number includes loading this page, figuring out, oh, you want to run PyScript in it. Oh, which one? Oh, MicroPython. Okay, let's start it up. And then it comes back and runs my logic. Then I have to construct this page, and then I say that took like 132 milliseconds. So this is on MicroPython. There's a lot of things you can do. It's a subset of the Python language. So some of the library are cut in half, so you only have half of the features. But things like, for instance, reflection isn't there. So you can't ask a method like, what is your doc string? Because MicroPython says, like, well, I'm running on embedded devices, who need doc strings, right? So it removed those. So if you want to see those, then you have to run on a real Python VM, like CPython. And then you can actually see the doc strings. So if I go to the doc strings, I can now see the doc strings for all these elements that I have. So the price we pay for this, it's longer startup time. You can see when I refresh this page, we're looking at white space, right? We're looking at a loader. So normally you would have like animations here to fill up this time and hide it from the user. But there's only so far that you can make this look fast. So that's why we can combine these two things, and that's the spreadsheet example. So what we have here is MicroPython running the UI. So I'll click on the bike store. So MicroPython is starting up, and it's starting up again in like 132 milliseconds. Then it run my page. My page is a little bit more complex in this case, so it has to go back to the database, retrieve like the structure of this spreadsheet, and then render it. And that takes a little bit longer, but if you look at the bottom, the beeper, there's a beeper. Is it out of time? Oh, I would have like expected a beeper like 5 minutes before. Anyway, so I'll wrap up. So you can see that MicroPython is starting up in about 0.1 second, because this is like the first kind of thing I can do in my Python logic. So that's about 100 milliseconds. Then after around a second, I'm done with rendering the UI. And in the meantime, the worker has started on a background thread. So this is using web workers, like standard JavaScript workers. And you can see that takes a little bit longer. So the PyData startup takes a bit while, and then building the whole environment, preloading pandas and matplotlib. But from that moment on, I can send work to that worker and not slow down the UI at all. Because in a web application, you also don't want to run anything on the main thread, because that will hurt sort of the interactivity in your application as well. So I'll make a change here. So this is now 55. I'll make this 500 to make it show up really well. And then go back to my chart. So in the bottom, we can see the workers getting requests to do something and then sending back results. So my data frame changed, and the dependencies, which are the images, also changed. So now the bike store is making most of its money from selling air, which is what we expect. And if I'll make it a little bit smaller so you can see the structure, and hide the logger here. So this is what the UI normally looks like.
And Chris, we really need to.
Now we're really into this, yeah. So hopefully you've seen like it's possible to write professionally looking, even though the styling needs to be fixed, professionally looking applications that start up really fast in Python using pandas and matplotlib, and they start up within a second, right? So this is like the golden mark that we had for Google Sheets that I established at the beginning. So if you're interested in this, go to chrislaffra.com, click on LTK, and build something. I'd like to see that. Thank you.